this video, I will explain what is a limiting reactant and how can you use the limiting reactant to calculate the amount of product in a reaction. A limiting reactant is the reactant that limits the amount of product produced. So the reaction will stop when this reactant has been completely consumed. So assuming a reaction between A and B that gives you P as the product, you need to write the balanced equation. So in this equation, 1 mole of A react with 1 mole of B to give you 1 mole of P as the product. If you have 4 moles of A and 3 moles of B, then when the reaction is complete, you're going to find that there are only 3 moles of P as a product that has been produced. And then 1 extra mole of A will remain. So the reaction will stop when all the reactant B has been consumed. So B now is the limiting reactant. Sometimes you will need to find out how much product is produced, or you need to find out which of the reactants is actually the limiting reactant. In this case, you need to write the balanced equation. So for a reaction, A plus 2B gives you 1P. Then if 0.751 moles of A are mixed with 1.43 moles of B, which one would be the limiting reactant and how much excess reactant remain unreacted in this case? So to answer this question, you need to write your balanced equation and then you need to find out if A is a limiting reactant, how much B will be required to completely consume A. Of course, we will need double the amounts or double the moles of A. So we will need 1.502 moles of B so that all the A will be consumed. But we only have 1.43 moles of B. That means that B here is the limiting reactant. And to find out how much or how many moles will be remaining unreacted from A, the amount of A that will be completely reacted by the time the reaction stops will be half the number of moles of the limiting reactant, which is B. So the amount of A that will react is 0.715 moles. So the amount left from A will be the 0.751, which is the whole amount minus the amount that is required or that has been consumed. And then this is the remaining moles, which is 0.36 moles. Now, the maximum amount of P that will be produced will depend on the limiting reactant, which is B. So half moles of the B will be produced as the product. So the maximum amount of P produced will be 0.715 moles. Sometimes you are giving questions where they give you the amount rather than in grams or in mass rather than in the number of moles. And then you are being asked to calculate the amount of the product produced from finding out which of the reactants is actually your limiting reactant. So let's have an example. So if they ask you to calculate the mass of aluminum oxide formed when 135 gram of aluminum is burned in air. So the atomic mass of or relative atomic mass of aluminium is 27. For oxygen, it's 16. To answer this question, the first thing you need to do is to write the balanced equation. The balanced equation here is for aluminium will react with 3 oxygen to give you 2 moles of aluminium oxide. Now you need to determine which one is the limiting reactant. Of course, oxygen will be in excess because its aluminium is burned in air, so oxygen will be in excess. So aluminium here is the limiting reactant. So all our work will depend on the amount of aluminium. So we need to work out the formula mass or molecular mass of all the reactant, the limiting reactant, and the product that is produced. So here aluminium is 27 and aluminium oxide is 102. Now we need to find the number of moles of the substance you know the mass of. We know the mass of the aluminium. So to find the number of moles that will equal the mass over the molecular mass or atomic mass. So there are 5 moles of aluminium reacted in this reaction. And now we will use our balanced equation to find how many moles of the product has been produced based on our limiting reactant. In the balanced equation, we found that 4 moles of aluminium gives you 2 moles of aluminium oxide. That means 5 mole of aluminium will give you 2.5 moles of aluminium oxide. So finally, you need to calculate the mass using the formula mass and the moles. So the mass of aluminium oxide produced will equal the number of moles times the formula mass or molecular mass, which equals 2.5 times 102. So you're going to have 255 gram of the aluminium oxide. Of course, when we did this